afternoon, everyone. Thank you, Margaret, and thank you for coming. So we've listened to Alex, and he talked to us about big data infrastructure, technology, and I'll take it from there. I'll tell you about the data science, which sits on the top of the big data journey, or maybe I should say as a natural, logical extension to the big data journey. But it's an important journey. So what I'm hoping in this session to do is to really get you very excited about data science by telling you how wonderful it is, how deep it can really push your learning experience, and then to tell you how impossible it is to achieve if you don't have the proper tool. So hopefully I'll give you this both sides of the coin. And I don't think we're short of hype. So everywhere you look around you, big data has been making a big noise. I can't think of one day that I actually spent without hearing big data. If I had a penny for every time I hear big data, I'll be a millionaire. So really, big data is around us. The problem is that, is it really delivering on the promise that it's making? Or is it more like the presidential campaign? Once it's done, all promises are gone. So hopefully by the end of the presentation, you'll have a better understanding of two things. And the two messages that I want to send to you is that number one, big data science and big data is more than the technology. It's about the people itself. So that's number one. And then I'm going to contradict myself, and I'm going to say it's even bigger than the people. It's more about the organization and the innovation that you create out of data science. And I can tell you I'm blessed to be in the position that I am because we deal with projects from different walks of life, from different industries, and we're lucky in that we build that relationship with a client to see how the impact had gone from almost nothing to everything. So big data is in the news. It's around us. It's making, whether it's, again, the uncovering polls about the presidential campaigns, it's solving real problems. It's the data, the new oil of all organizations. But big data is really hard to attain. And this is not my code, but the hard truth about big data is that it's like teenage sex, okay? So everyone talks about it. And nobody really knows how to do it. And everyone thinks everyone else is doing it, so they claim that they're doing it, okay? This is not my quotation. But I will add one important piece. Big data is a lot like this, is that if it's done unprotected, it can actually create a lot of harm, okay? So and we've seen different sides of big data and data science. So are organizations really uncovering the information goals? I have been in the domain for more than 15 years. I started out I used to be a computer science professor at the University of Texas. Started an organization or a small research lab, actually grew into a large center called VIB, Vision Intelligence Bioinformatics Research Center. And if you asked me back then, would you be in the position to look at customer behavior, look at who's more likely to default on their loans, and where is the next security threat is coming from, I would say in my wildest dream, okay? But really, big data is about answering all these hard questions. Do you really, as an organization, do you really know your customer? Do you know what are they buying? Do you know what's driving them to buy? Do you know, can you predict his needs and aspirations? And can you exceed his expectations? Can you actually prescribe something that he wasn't even aware that he needed? So really, big data and data science, I think there was a discussion earlier about, what is different between reporting and data science. And I think one of the 10 cents contribution that I can say is that big data or data science is supposed to uncover something that you have not known before. Or maybe you've known it in your heart, but you needed the data to really prove it to you. So, and we have a say with Cognitro, within Cognitro, we say, what are stories but data with souls, right? So, do you think you know your customer? Your customer could have a multiple size that you were not aware of. In fact, there was an article that I liked reading the other day, actually quite some time. It says, who knows you better, your family or your credit card company? And of course, with data, there are a lot of things that you can predict. But we have been, as Cognitro Analytics, we have been in the domain for over 10 years. We started out back in 2005. Like I said, got seeds funds from National Science Foundation. There was a guy by the name of Alan Taft. He was a NASA JPL, Jet Propulsion Lab scientist. We got together. He was predicting the age of the universe from Hubble telescope data. I was looking on the healthcare applications, looking at microscopic imaging data to determine the spread of cancer. And we decided that we were really in the area of artificial intelligence. Of course, it was not called big data. It wasn't called data science. It was just data. We were just trying to infer data on scientific research. And then the company grew. Eventually, we got incorporated and then moved to New York. And then recently, we just moved to Dubai and started going internationally with our competency. We have offices in New York and Dubai, serving clients in the US and internationally. And we claim to have the whole story. So anywhere from building your data science strategy, how do you collect data, how do you prepare the leadership and the organization for undertaking analytics or undertaking real data science project, all the way to really developing all the algorithms and the analytics that really will mean the difference in your bottom line as a company. And we've been pushing the analytics rigor to address increasingly complex questions. So I have a lot of stories that, as you can imagine, to offer and to share in terms of how we've changed the lives of, or the businesses of industries around us. The one that we brag about the most is that we predicted the crisis, the financial crisis in 2009 in Dubai. And again, we were able to look at trends that actually proved to be the case. We just wrapped up a project where we answered, how do you predict the security landscape within the country? We're also doing a lot with healthcare in terms of building a national e-health analytics transformation programs. We're looking at the signs of how the economy is trending. So for example, we're looking into the movement of people as it relates to the GDP. And this, of course, becomes of importance for economists, along with other things. But really, the single most important question that we have been trying to answer all along, and I think one of the success that we've had is turning the lens into ourselves and asking, what constitutes a good data scientist? What is the DNA of a real data scientist? Which I think is a question that almost every organization is trying to answer. And the argument that we have, if I can get this thing to work, do we have a malfunction here? Okay, so you've heard this before. Data science is about having the mathematical background, having the business strategy, the technology hacking skills, and it's really different in these things from the traditional analyst, right? And if you're a data scientist, presumably they ask you to know all these algorithms, which of course is impossible. So the question was always in the back of our head, is there really a unicorn data scientist? Is there one guy in the room here who knows anything and everything about these different models that you were supposed to apply in order to really uncover the informational gold? And we say that our answer was, let's look at what the industry would say. what the science would say. So in a way, we turned this into a data mining program or data mining project. In essence, we use analytics to understand the real DNA of data scientists. And we looked at 3 different categories of behavior. So we looked at the personal attributes, environmental attributes, and behavioral attributes. And as you can see, within the environment of a real data science lab, you have many factors that comes into play. The type of data that you're faced with, how do you sample the data, all the way to how do you really tell the story. And data science is also part of it, is how to tell the story to management. And how do you really convince who we call the recipients, right? Because you're cooking this healthy meal of analytics and you're delivering it to people that are going to ultimately make the decisions. So if that meal is not healthy and tasty, of course, the recipient or acceptance will be limited. So the most commonly used algorithms, as we have expected, are really those that are at the very low end of the analytics sophistication. So most people would really focus on the ones that are built in within any technology or analytics platform. So usually you start with regression tree, decision tree. Those are the ones, again, easy to interpret, easy to work with. As you start getting more complex, the type of skill sets that required for this start to be diminished. So we developed some indicators. We said that if we can uncover the trends to show that there is a cognitive, what we call the cognitive myopia, then we can say that this myopia exists. So in essence, what you get is a recipe for organizations of how to use data science. And so the question was, for companies, who should you hire as a data scientist? What are the attributes? The environmental attribute, the personal attribute, and the behavioral attribute. There was a study that was run by Kaggle to predict readmission in the healthcare. And this was I think it was $3.5 million prize that was offered to this who can predict readmission in healthcare with the highest accuracy. And believe it or not, it was not a company that got the award. And it was not a group of people. It was one guy from East Europe who learned analytics from social media. So that tells you, again, that confirms a lot about what we uncovered in this study. So now coming back to the second case study that we had. So really taking now going from almost an organization. This is a classic, this is a project that we've done in the West Bank. If you're familiar with the West Bank, this is a place that is under occupation. It's undergoing a lot of severe, harsh environment in terms of movement of goods and people. So there was 27 hospitals that was asked by USA to fund the project. But in any case, we were asked. We came in. We built this national e-health project. We were able to show how the data could support decision making. And then we also put some analytics to show how it can drive decisions. So we were able to increase referrals by 35%. And we were able to transfer this to the Ministry of Health. And then we were able to drive innovation through the analytics. So as a result, one big factor that we saw was that the movement of people was the second factor for the expenses, the general expenses, unnecessary expenses in the West Bank. As a result, there was a movement towards starting a startup company. So we started a new company to actually deliver to solve the problem. And as a result, this Gravilog application, which allows communication between the patients, pregnancy women, and the doctors to be streamlined. And as a result, it started a new set of data, which allowed us to even do more analytics. And this is what I really call by continuing the journey of analytics. If analytics really does not spur an innovation on itself, then it really becomes flawed. So, and that's what we call the 3 returns: return on investment, return on insights, and return on innovation. The key for it is really not just the technology, as I show. It's technology, governance, competency, and culture. Again, leadership is important. But I can tell you, it's much like sex. It gets better with practice. Okay? So the longer that you apply data science, you're able to really move from where you're at today to where you're at tomorrow. And we can help. We have a framework that really allows you to, that takes any organization from the very early stages of maturity to the end stage. So engage, empower, enable, educate, energize. And really, this is the framework that we offer to our clients, and it has been very successful and fruitful. I don't think I have time to go more. There's one thing that I want to do, that I want to show, is that you always want to start with an assessment. You want to see, if you want to look at where you want to be, you want to look at where you are today. And we're able to do this using our maturity assessment framework, which allows you to really look at, how star of 5 stars, again, much like the 5-star rating. It allows you to see where you're at on the maturity scale. And then we have the recipe to even drive it further to really get you from the 1 star to the 5 stars. We have collaborated with the University of DePaul, and we're working with them to develop a complete end-to-end training program that allows organizations to really upgrade their capacity and reach their data science goals. Thank you. Open the door for questions. Do we have time for questions?
Maybe one.
Yes.
Yes,
I'm intrigued by your project to measure the effectiveness of what makes a good data scientist. What did you use to, metric or metrics did you use to measure good when we talk about good data scientist?
That's a very good question. So believe it or not, there were multiple criteria, but really the one factor that we used is whether the project, the team, where the data scientists are embedded in, are able to sell the insights to the decision maker. So it's deployment. It's really deployment. If management have adopted those insights and they are actually using it within the bank branches to on daily basis to create and to optimize operations, then we use it. Then we say that this is a success.
So it's a yes/no.
It's a yes/no. Yes,
right, okay.
It's a yes/no.
Hi, thank you for a wonderful presentation. I just want to know, many academicians, many PhDs are turning up to data scientists. So how do you think, the people of such role who have been doing PhD or mentoring it, do you think they are better data scientists?
I used to be a professor of computer science and artificial intelligence, and I think maybe my testimony would be biased. Or myopic. I would say that it's not necessarily the case, because I think we're coming to a point where even the data science skill sets are differentiated. And I would say that it's wrong to assume that one data scientist fits all, right? And I think for the types of problems, for example, if you're trying to work more with unstructured data, then naturally you need different types of skill sets. You want to focus more on the natural language processing versus if you're doing more with network analysis or social network analysis, then you need someone more on the graph theory and so on. So there are a lot of caveats. And even our experience was, the people that are involved in developing the data, or I would say that where the 70% efforts comes in, which is the data quality, there are specific skill sets that you need. So I would say even within a data science team, you probably need to segment your data scientists so that the distribution of skill sets are complementary, if that answers your question. But of course, it does help, especially if you are, naturally, if you come from an engineering or the mathematics background, it helps understand the intricacies of these models and how they're applied. But I think nowadays, if with all these, if you know just enough to know how the model is applied, but also to learn how the model should not be applied, because sometimes it can backfire, then you're okay. But I would say put more emphasis on how much they have done analytics versus how much they know. Because at the end of the day, that's what's going to matter. Have you done it long enough? Have you achieved success, from applying your analytic skill sets? And have you developed what we call the data science intuition, the feel for the data, right? So, hope I answered your question. Any more questions? Okay, thank you very much.